Hello everyone and welcome to our video tutorial, and today we will be discussing as well as studying the inverting configuration of an op-amp. Talking about the inverting configuration of an op-amp, an inverting circuit inverts the input and show it as the output waveform. The input signal is applied to the inverting input terminal through R1 and non-inverting terminal is grounded. The output VO is equal to Vin multiplied by minus RF by R1 and gain is equal to minus RF by R1.
The circuit diagram that we would be using today. Apparatus required: CRO, BNCs, connecting wires, multimeter, set of resistors, breadboard, function generator, DC source, 741 IC. We just placed 741 IC over our breadboard. Now I would be grounding the pin number 3, that is the positive pin of our 741 IC. Now applying R1 from the pin number 2, that is the negative pin, to the V input. Applying RF from the second pin, that is the negative pin, to the 6th pin, that is the output pin. Now I would be applying the input BNC from the function generator, setting the ground. Now applying the output BNC. Now it's time to apply DC biasing, applying minus 15 volts to the 4th pin, that is minus VEE, setting up the ground connections, applying plus 15 volt to the 7th pin, that is plus VCC. So now our circuit diagram is complete. Case number 1, that is R1 equal to 3.2 kilo ohms and RF equal to 8 kilo ohms. Note down that channel 1 and channel 2 are at 5 volts respectively. The upper waveform is our input waveform and our lower waveform is our output waveform. Calculating our upper waveform, it is 0.2, 0.4, 0.6 and it's 0.8. So V input is 0.8 into 5 volts. Now calculating our output waveform, it is 0.2, 0.6, 0.8 and 1, and it's 1.2, 1.4 and 1.6. So V output is 1.6 into 5 volts.
Now the calculation and observation, as we all know that gain is equal to minus RF by R1, which is also equal to V out by V in. V in is equal to 4 volt as we observed earlier, and V out is equal to minus 8 volt since it is the inverted version of the input waveform. RF is equal to 8 kilo ohm and R1 is equal to 3.2 kilo ohm. Now calculating the gain practically, it is minus 8 divided by 4, which is equal to minus 2, and gain theoretically is equal to minus 8 divided by 3.2, which is equal to minus 2.5.
Case 2, R1 equal to 3.2 kilo ohms and RF equal to 11.5 kilo ohms. Note down that channel 1 and channel 2 are again at 5 volts. Upper waveform is our input waveform and lower is our output waveform. Our input waveform is kept same, so it is 0.8 into 5 volts again. Calculating our output waveform, it's block number 1, block number 2, then it's 2 and 2.4. So output waveform is 2.4 into 5 volts.
As now we calculated that V in is equal to 4 volt and V out is equal to minus 12 volt. RF was 11.5 kilo ohm and R1 is equal to 3.2 kilo ohm. Again calculating gain practically, which is equal to minus 12 divided by 4, which give us minus 3, and gain theoretically minus 11.5 divided by 3.2, which gives us minus 3.6. Now we just observed and calculated gain in inverting configuration, and now it's time to stimulate it over multisim.
Let's place 741 IC over our console window. Now placing oscilloscope and function generator on the console window. Placing a resistor of 3 kilo ohms and 1.5 kilo ohm respectively. Now applying 1.5 kilo ohm to the negative pin of our 741 IC and 3 kilo ohm from the negative pin of our 741 IC. Now grounding the positive pin of our IC and applying the input to the 1.5 kilo ohm. Now we applied to the channel AR input voltage, applying VCC and minus VEE to the 741 IC and adjusting their value to minus 15 volts and plus 15 volts respectively. Applying the output to the B channel of our oscilloscope. Now applying the ground connections. Negative and the negative pin of A and B are grounded. Now it's time to simulate our. Double click on the oscilloscope. Reverse the mode. Now adjust time base and scale for channel A and channel B in order to get the perfect waveform. So this is our desired output for our inverting configuration. The upper one is our input waveform and our lower one is our output waveform. Now see, channel 1 is at 10 volt per division and channel B is at 10 volt. So we can see the amplification is done here. So this is our output waveform for inverting configuration C, and this is very much similar to what we observed in our practical.
This was all about the inverting configuration of an op-amp. Thank you for joining us in this video tutorial and hope you understood the inverting configuration of an op-amp. All the best.